Hi, so today I'm going to be talking about matrix calculations, and this includes matrix addition, matrix subtraction, scalar and matrix multiplication, as well as matrix multiplication itself. And to start things off, we are going to be starting off with matrix addition. So matrix addition, there is one rule to keep in mind, that is that when you're adding matrices, the dimensions of the matrices that you're adding should be the same. So in this instance here, you can see that the first matrix, it has 2 rows and 3 columns, while the second matrix here has 2 rows and 2 columns. Because the number of columns are different, the matrices cannot be added. So moving on to the green color matrices, over here we can see that the first matrix has 2 rows and 3 columns, while the second one has 2 rows and 3 columns as well. And because the number of columns and rows for both matrices are the same, the matrices can be added. And how you add the matrices is basically, for example here it's 2 plus 1, and then you will get 3, and then it's 4 plus 4, you will get 8, and then 6 plus 3, that will give you 9, and so on and so forth. And it will be the resulting answer, the matrix that you get as your answer, will have the same dimensions as the matrices that you are adding. For example, the answer here would also be 2 times 2 by 3. It's a 2 by 3 matrix, that means it also has 2 rows and 3 columns. So here you can see the answers. So 2 plus 1 would give you 3, 4 plus 4 would give you 8, 6 plus 3 would give you 9, 7 plus 6 is 13, 8 plus 9, 17, and 9 plus 5 you will get 14. And then moving on to matrix subtraction, over here it follows the same rules as matrix addition, in the sense that the dimensions of the 2 matrices that you are subtracting should be the same. In this case, the first matrix is 2 by 2, which means it has 2 rows and 2 columns, and the second is 3 by 1, which means it has 3 rows and 1 column. So therefore, because the dimensions of the matrices are not the same, they cannot be subtracted. And then if you look at the purple color matrices, so the first one is a 2 by 2 matrix, which means it has 2 rows and 2 columns, while the second one is also a 2 by 2 matrix, and therefore we can subtract the 2 matrices. And the subtracting matrices follows the same rules as adding matrices, as I mentioned, and the resulting answer, the answer matrix, will also have the same dimensions. So here 2 minus 6 would give you minus 4, and then 4 minus 2 would give you 2, and so on. So I'll just reveal the answer here as well. And as you can see, it's minus 4, 2, and then 3 minus 1 would be 2. 6 minus 4 would also give you 2. So that is the answer for that. And then we'll move on to scalar and matrix multiplication. What this basically means is multiplying an integer with a matrix. And in this case, it doesn't matter what dimensions the matrix has, so long as you're just multiplying it with a scalar number. It's an integer, so it really doesn't matter. And in this case here, 6 into 2 would give you 12. I'll just reveal the answer right now. So 6 into 2 would give you 12, 6 into 4 would give you 24, and 6 into 3 would give you 18. And the resulting answer would be of the same dimensions as the initial matrix. And then over here, it is purely the same concept. And as you can see, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on and so forth. And as the matrix that you're multiplying by 5 is a 3 by 3 matrix, the answer would also be a 3 by 3 matrix. Now, when it comes to matrix multiplication, there are a couple more rules. So to decide whether 2 matrices can be multiplied with each other or not, you have to see their dimensions. So in this case, the first matrix is a 2 by 2 matrix, while the second one is a 1 by 3 matrix. Now you have to look at the number of columns and rows. So over here you have 2 rows and 2 columns, while the next one, the other matrix, has 1 row and 3 columns. To be able to multiply 2 matrices together, the number of columns in the first matrix should equal to the number of rows in the second matrix. So in this case, because the number of columns in the first matrix is not equal to the number of rows in the second matrix, they cannot be multiplied. However, here in this case, the first matrix is a 3 by 2 matrix, which means it has 3 rows and 2 columns, while the second one is a 2 by 3 matrix, which means that it has 2 rows and 3 columns, because in this case the number of rows and columns, as in the first matrix, number of columns in the first matrix is equal to the number of rows in the second matrix. Therefore you can multiply the two matrices, and the answer, the resulting matrix, would be the dimensions of the answer would be of the number of rows in the column in the first matrix, as well as the number of columns in the second matrix. So because the number of rows in the first matrix is 3 and the number of rows in the second columns in the second matrix is 3, the resulting matrix would be a 3 by 3 matrix, and which means 3 rows 3 columns. And when you're multiplying matrices, basically the idea behind it is that you multiply each row of the first matrix with each column of the second matrix. In this case, you multiply 3 by 3, which will give you 9, and you add it by the multiplication of 4 by 6. So 4 times 6 is 24. So the answer for the first number of the matrix would be 9 plus 24, and I'll show you here, which would give you 33. So that is how you do it. And then in the second number, how I've gotten 39 is 3 times 1, which is 3, plus 4 times 9, which is 36, and that will give you 39. Because you're adding 3 plus 36, you would get 39. And then how I got 43 is 3 times 5, which is 15, plus 4 times 7, which is 28. And then you move on to the next row. So in the next row it's 7 and 2. So 7 times 3 is 21, and 2 times 6 is 12. So you add 21 and 12 and you get 33. And then you move on to that row and the next column. So 7 times 1 plus 2 times 9, you'll get 25, and you continue doing that till all the numbers are covered. And then this second set of matrices, it's the same idea in this one as well. In this one, the dimensions of the matrix are different, but yes, you can see the first matrix has 3 columns and the second matrix has 3 rows, and therefore they can be multiplied together. And because the first matrix has 2 rows and the second has 2 columns, the resulting matrix would have 2 rows and 2 columns. And as you can see here, how I've gotten 58 here is 1 times 7 plus 2 times 9 plus 3 times 11, and that's how I've gotten 58. And then 64 is 1 times 8 plus 2 times 10 plus 3 times 12. And then 139 is 4 times 7 plus 5 times 9 plus 6 times 11. And then that's how you just use the same logic to get 154 as well. However, something to bear in mind when you're doing matrix multiplication is that if you're multiplying two matrices, so for example A times B, it will not be equal to multiplying B times A, because either the matrix dimensions could be different, or the values that you're getting at the end, it could be different, or you can't multiply it at all. It's not going to give you the same answer, which is why you cannot multiply B times A if you want to find what A times B is. It's not going to give you the same answer. And as you can see here, you got two 2 by 2 matrices. So the first one is 1, 2, 3, 4, and the second one is 5, 6, 7, 8. And here to get 19, what I've done is multiply 1 times 5 and added 7 times 2 to 1 times 5. So 5 plus 14, and I've gotten 19. And then as you can see in the second one, where I've swapped the matrices, so I've gotten B first and then A. In that one, because I'm multiplying 5 times 1 first, so it's 5 plus 6 times 3, which is 18. You're getting a totally different value, which is 23. And in comparison to the first matrix, which I've gotten 19 for, clearly you can see that A times B is not equal to B times A. And yeah, so matrix division doesn't really exist. It doesn't exist. So, but if you were to find the value of, let me just draw it here quickly. If you were to find the value of C, given that value of B, given that you know matrix A, and you were to multiply it by B to get C, and let's say you know the value of A and C, but you don't know what matrix B is. So to find matrix B, what you would do is, because you can't divide it, it would be B equals to A inverse times C, and in one of the upcoming videos I will get into how you find the inverse of a matrix, inverse of a 2 by 2 matrix as well as the inverse of a 3 by 3 matrix, and that is how you find B, which is the unknown matrix in this sense. So that I will get into in one of the upcoming videos.